First, before we begin, there's some formulas that we should know. So when you see the word of, kind of like in this question 1, of just means to multiply. So this is the easiest type of questions. When you see questions like number 1, 10% of 470, it just means, in other words, multiply by 10%. Now when you multiply by percentage, you have to change to decimal format, so it'll be 0.10, and this will give you 47. There. Although it's a simple question, if you don't know the wording and what to do, it can be confusing. Now another type of question is percent increase or decrease. Okay, so these get a little bit more tricky, but the only formula that you really need to know is final value is equal to initial value, and then you do 1 plus p, which is percent, over 100. So if it's 15%, you put the p as 15, so you'll do 15 over 100. But I'll show you how that works here. So let's try number 17. I would say this is in between medium and hard level question. So each year the value of an investment increases, okay, by this much percent of previous year. Okay, which of the following functions best models? Okay, so forget the second part of the question. Let's just set up the equation for the first part of the question, and then we can look at the second part. So since we're doing percent increase, we're going to do this same formula that we looked at. So let's just say initial value is the previous year's investment. So 1 plus, in this case, is 0.49 over 100. And this will equal to this following year's investment. Okay, now we can look at the second part. Which of the following functions models how value investment changes over time? Okay, so for this question, it's actually has to do with exponential growth, because there's a 1 over here. So this happens each year. So if you want to find out how much it increases in a span of 2 years, you would put a 2 here. So in other words, whatever value you start with and how many years pass. So this question is asking how the value of changes over time. So basically time is your variable. So your x will go here, or t is what's commonly used. So the number in the middle of, or inside the parentheses, does not matter too much, but it's good to know how to set it up. Okay, so now the question is basically asking what kind of function is this? Well, because the independent variable, is on the exponential term, this will be an exponential function. We can get rid of that. And now, if as time goes by, if the final value keeps increasing, this is an increasing exponential function. The question is a little bit tricky, but we want to pay attention to what the question is asking. Investment changes over time. So we want to know where to put this function, and this is how you will set it up. Okay, let's go on to the next question. Okay, the population of Greenville increased by 7% from 2015 to 2016. Okay, so the 2016 population is k times the 2015. What is the value of k? Okay, so we want to find out. So we don't have any numbers, really. We don't know the initial population or the final. So we're going to use a variable for this question. So let's just say x is our initial starting amount. We know that the increase is going to be 1 plus 7 over 100. And this will get us to the final value, right? Again, this is 1 because we're only doing this once. We're doing this increase once from 2015 to 2016. If we were going to 2015 to 2017, we would put a 2. But in this case, we don't have to worry about that. Okay, so if we start with x, the final value, if we do this, is going to be x times 1.07. So it's 1.07x is the final value, right? So if we start with x and we end with 1.07x, we're comparing these two, because this is what you'll have in 2016, and this is what you'll have when you're starting 2015. So no matter how many you start with, your ratio, you can plug that into here, and this will be your how much you increase by. So the question is asking 2016 is k times the 2015. So k times x. So your x will be 1.07. Yep. These are some of the percentage questions that I have found. Number 17, I think it's a little bit harder. Number 18, you gotta get used to using variables because you can't always plug in numbers. Yep, I hope this helped.